Okay, good morning and welcome back. Before we start, I would like to make some announcement. First is because total number of students is more than 100, so we will use Cisco. Total number of students is more than 100. Too much noise. Okay, that's why we use Cisco WebEx. The advantage is this software allows more than 100. Okay, so we can accommodate all the students at one time. So we don't have to worry too much. And on the other hand, I will record the video, upload to YouTube. So you can also access the course materials through the following link. Just a moment. Let me change to laser pointer. So you can connect this lecture room through here. And also you can access the YouTube through, that's the video of this Tuesday. And that's the channel. Okay, that's the major change. Second, just a moment. Too much noise. The second change is here, the schedule. This is the correct schedule. So next Tuesday, we have no class. And then next Thursday, we will continue talking about chapter 1. Can you see me all? 我没有办法把进入跟关掉的声音关掉，到目前为止找不到方法。I don't know how to turn off the noise, the sound. Okay. Today, we will talk about chapter 1. Chapter 1. So let's move on to chapter 1. Today we will cover two sections. Chapter section 1.8, Green's theorem, and section 1.9, the uniqueness theorem. Okay, these two theorems are very important, especially the Green's theorem. We will use Green's theorem over and over again. Over and over again. The Green's theorem will be why the Green's theorem is so important. It will be used for various boundary value conditions, from electrostatics, magnetostatics, and from EM wave. Okay, that's something new. It's different from electromagnetism. So it's something new, completely new information. So please sit back and fasten your seat belt. We are going to take off. Okay, 准备起飞咯。Let's start with the Green's theorem. Green's theorem is a powerful tool for treating all the problems, boundary value problems. Yes, boundary value problems with the boundary. So it's a simple applications of the divergence theorem. So first, I will show you the divergence theorem once again. This is the divergence theorem. Divergence, that's the volume. That's the surface enclosed this volume, just like this one. V is the volume, Tg. S is the surface enclose this volume, enclose this volume， 包括整个体积。OK， enclose the volume. How to turn off the noise? Just a moment. Let me try again. But I really don't know how to turn off the noise. I'm sorry. Although I use Webex a lot, but never as a chair, as a host. So I'm not very familiar with this software. Too much noise. Okay, anyway, Hongjun, if you found the solution, please tell me. Okay, so this is the divergence theorem. Divergence A, volume integral, 体积分 is equals to the surface integral, 面积分，包括了整个面 surface integral. So we have used this symbol to denote we surface integral the entire surface, Okay. So just if this is a volume, and surface means the surface enclose this volume. Okay. How to apply this divergence theorem? Simple. We just assume A is a vector, and A can be a scalar function, phi and psi. So phi psi here. Theta is another one, just for your reference only. Here we just use phi and psi only. Okay, so A equals phi times gradient psi. Gradient psi is a vector times a scalar is still a vector. So phi times gradient psi. So where phi and psi are arbitrary function of position, they are function of positions. Depends on s, y, z, r, theta, phi, rho, phi, z. Okay, depends on position. Later on, it can be depends on time. Okay, but here we just consider phi and psi just depends on positions only. Therefore, divergence A, this is a vector. We can rewrite this one into phi Laplacian psi plus divergence phi divergence psi. Okay, so divergence of a vector is a scalar. So this is a scalar. Therefore, Laplacian of a scalar function is a scalar. Scalar. Okay? It's scalar. And A dot n, A is a vector, n is the unit vector perpendicular to the surface from inside out, pointing outward. Okay, so A dot n just indicate phi gradient psi dot n. We have a shorthand notation. 简写 Let me show you. I changed to this one. Here we can use shorthand 简写缩写 shorthand notation just like this one. It's still not very convenient. Let me try if I use this one. Not good. Erase everything. Okay, it's just a shorthand notation. It's the normal component of gradient psi. It's a shorthand notation here. Normal component of gradient psi. From this one, you can write into this one. It's shorthand notation. Okay. It's so that's the one of the first problem, because most of the students will be confused here. They don't fully understand what's going on here. They don't fully understand the meaning of the symbol. Let me say that again. The normal component of gradient psi pointing from the bottom inside out. Okay? Pointing from inside out. Just a moment. 开启参加者的面板，联合主持人的出席。但是我现在设不过去。Here, assign 参加者。Just a moment. And and
教授，你看得到那个聊天室的讯息吗？
可以，我现在正在指定为主持人，所以洪俊让你去当主持人哦。
喂，老师，麦克风试音。
可以，我听得见你。你现在变成主持人了，有看到吗？
我现在是，我现在是。
那有进入就由你来按了，我这边就听不到了。
好，我有把那个离开的声音关掉了。
试试看是不是可以就解决掉这个问题。
好的啊，那老师那个聊天室，我其实蛮早就有那个打字跟之类的，是有延迟吗？还是
没有？因为我在上课没时间看。
好，没关系。我以为我的那个讯息老师那边都看不到。
不是，没有空看。
好
上课
，OK，
很忙，
那应该没问题。
正在开飞机的时候。
好，那我们继续起飞。
OK， 继续飞哈。
好
OK，let's continue. Okay, so just a shorthand notation. You should gradually familiar with this kind of shorthand notation. Jackson, unlike Griffiths, he preferred shorthand notation. Okay. So Jackson will use a lot of shorthand notation. Substituting these two expressions, this one and this one. Just a moment, let's change to pointer. These two expressions for divergence A and divergence A dot n, the normal component of A into the divergence theorem, we obtain Green's first identity, simple identity. Just substitute this one, two terms to here. Here we have two terms, but here, Green's first identity, we have three terms. 1, 2, 3. Okay, now let's interchange phi and psi, change the order. We assume A is psi gradient phi, and then substitute the new A to here. Just interchange phi and psi. We got another one. Also, it's still Green's first identity. No problem. Okay, but let's have a closer look at these two equations. These two equations shows that A dot B equals B dot A. Okay, so gradient phi dot gradient psi equals gradient psi dot gradient phi. Therefore, we can subtract these two and cancel these two. So we have subtracting these two equations, we obtain Green's second identity. First, second, this one minus this one minus this one. So here, that's the Green's second identity. I use the blue color to highlight the importance of this one. That's the Green's first identity. That's the Green's second identity. What's the advantage? It's not clear at this point, but at least we know one thing. This is two terms, 1, 2. And here we have 1, 2, 3. And then we have 1, 2, 3, 4. So we expand the Green's theorem from 2 simple terms to 4 terms. Looks like we are asking for trouble. 自找麻烦. Okay, is that true? Of course not. Although we have 4 terms, but later on, we can simplify into 2 or 3 terms. Depends on the boundary value problems. Okay. Next slide. Green's theorem relates a volume integral to a surface integral. Volume integral 体积分 to a surface integral. From the volume integral to a surface integral. This is the surface integral. Volume integral, surface integral, just like divergence theorem. The advantage, let me show you a simple advantage. We may convert the Poisson's equation into an integral equation. Okay? So let psi be this one. This is psi. And then Laplacian psi will be this one. If you remember, when you are undergraduate student, sophomore, we learned this one before. So that's not new to you. Okay? However, because you have a long summer vacation, therefore, I will show you this one again. Problem 2 later on. And we will show you this, how to derive this equation again on page 18. Okay? Phi be the electrostatic potential. And psi is this one. 1 over x minus x prime, absolute value. And psi will be, phi will be phi again. Okay? Phi will be this phi. This is capital phi, italic phi. 斜体字的 phi, 大写字的 phi. Okay? This one is Laplacian. Poisson's equation. So this is Poisson's equation. Therefore, rho will be function of position. And this is unprimed system. And actually, we can change the variable. The integral to the prime system. Prime, P-R-I-M-E. Let me write it again. P-R-I-M-E. Prime. OK， 有一撇的叫 prime， 没有撇的叫 unprime。很多人会念成 plum， 正确的念应该是 prime。OK，prime system。Laser pointer。Okay, this is prime system. So we change the variable. The change variable first psi is here. Substitute this term to here, and phi is here. The same. Phi the same, and Laplacian phi will be Poisson's equation will minus rho over x, but rho will be function of prime system, and epsilon naught here minus, so it becomes plus here. d3x prime. This surface volume integral, and surface integral will be here phi partial n prime, just shorthand notation, minus this one, partial phi partial n. Okay, if x, the value, the x inside the volume, then this one will be delta function. I will show you the function of delta function very soon. Actually, you learn delta function several times, but I still want to give you another chance to familiar with delta function, because for electrodynamics, we use delta function a lot. Yeah, because delta function is quite important. We use delta function a lot. Okay? Delta function, just a moment. Right now, we have 87 participants. Actually, less than 100. If all the student is less than 100, we don't have to change to WebEx. We can still use Google Meet. Okay, anyway. Okay, so what will happen? This one will give us change to only condition x equals x prime. Only when x equals x prime, we have value. So you can rewrite into phi of x. And then the other terms can move to the right-hand side, and minus divided by 4 pi, minus sign becomes here. And this one is here. Whoa, we're familiar with this one. We saw this one before. But we have two extra terms. First one is this one, divided by 4 pi. First one is this one, okay? Because of our minus sign, so this one moved to the front. And second is this one. So you can see here, the potential is related to the charge distribution, and also depends on potential itself. So it's not a solution, not a simple solution, but an integral equation. It's an integral equation, phi. So it's an integral equation, not a simple solution. However, in infinite space, 无限大的 infinite space. Let me show you. In infinite space, we have phi is proportional to 1 over r. Hence, this equation will reduce to, because contribution from this one will be very small, very small, 1 over r. 1 over r squared. So it's 1 over r cubed. 1 over r cubed. 一减 s 减 s prime 的3次方。3次方这边才2次方。Therefore, the contribution from the surface will be 0 if the space is infinite. Infinite 不是 infinite 哦，是 infinite， 是 infinite space。很多人会念成 infinite， 实际上是 infinite。Infinite space, okay, not infinite. Very large space. Very large space. Okay, so this the simplest case. So you can see the advantage of Green's theorem. Green's theorem consider finite space. Finite. 有限的 space, not infinite space. If the space is infinite, that will be easy. Just use this equation. But now, if the space is finite, for example, if you are doing an experiment at your lab, your lab space is finite. So it's impossible to consider infinite space. Very difficult. Very difficult. Okay. Therefore, Green's theorem, Green function, allow us to consider finite space. That's the major advantage of Green function, Green's theorem. Finite space, because of volume can be finite. Space, surface is also finite. So that's the advantage of Green's theorem. Any question so far? You can ask any question now. Okay, no response. I don't know your status. Can you hear me or can you see the slide?来，丁建军，可以听得见吗？ Turn on your microphone first, and then answer my question. Any question or problem about Green's theorem? 丁建军有在吗？ Yes. Say something, not just type. Say something. Otherwise, I don't know you are there or not. Try your best to say something. Okay. Anyway, you do not have a microphone. Okay, the good excuse. Looks like the COVID-19 is, although we have a Delta covariant, Delta variant, Delta 变异株号 Delta variant, and the Delta notation is exactly the same as this one. Delta function is Delta variant, but here the Delta variant is quite total number of infected case is still limited to single digit. So probably we have a chance to go back to our classroom soon. Yeah, probably. Best wishes. Okay, anyway, if we cannot go back to, okay, 谭道宁, you can ask a question now. In
Hello.
Chinese or English?
Can you hear me?
Yes.
So I have a question about a sentence on Jackson's textbook, and it says we can also consider an open surface. But here in Green's theory, because it's actually based on the divergence theory, so the surface we consider is always closed. Then why he mentioned about this.
Open surface is not, the definition of open surface is not clear. Okay, so you can skip Jackson's description at this moment. Actually, Jackson means all the surface, infinite space. Actually, Green's theorem can be considered finite space and infinite space. So both cases can be applied to Green's theorem. So there is no open surface. What do you mean by open surface? I don't understand. What is open surface? 难道你有 comment 吗？ What is
Non-closed surface. I guess that's what he means.
All the surface should be open surface, for example, just a plane. Just a plane, okay? Infinite plane, just a plane. This infinite plane, okay? Actually, we will deal with infinite plane with image theorem, master of image, 镜像理论. Later on. Okay. Open surface do not enclose, but actually it's still enclosed by infinite space. Very, very, very far away. Very, very, very far away. Maybe Jackson's mean is like this one. Okay.
Yeah, I guess that's what he means. By sending other parts of surface to infinity.
Yeah. Open surface, just like infinite space, actually is not enclosed by something, by a surface. It's infinite. Okay. Okay, any other question? Any other questions? Any question is welcome. If you ask a question, I will slow down. That's good for you. Hi, 胡汉林。
老师，我可以用中文吗？
可以。
好，老师，所以我们这里用 Green Theorem 的优势是说，我们可以得到一个在一个 finite space 的更广义的答案吗？
对。
好，谢谢老师。
记得我们在大二的时候学到的都是无限大的面积，都是很简单的式子，都是考虑无限远的、无限大的，没有考虑 boundary condition 的贡献。可是现在我们可以考虑那个边界的贡献，所以这个对我们做实验来讲，对实际的 realistic case 来讲会比较实际一点。所以 Green Theorem 就是因为它好用、实际，而且可以考虑到 contribution from the boundary, from the surface. Okay, any other questions? Any question is welcome.
Hello. Sorry again.
What's your name?
谭道理.
Oh, 谭道理 once again. Okay.
Yeah. So another question is why we take the form of that field A in that form. I mean, we can also consider A to be this form plus with another scalar.
You mean
in your previous slide?
This slide?
Yeah, so we take A to be that form phi gradient aside, but I mean, we can also plus another scalar.
Yeah. That's okay. That's for our convenience only. Actually, divergence theorem, A has no requirement. You can have any form. Divergence theorem should be correct. Okay, but just let A to be this one.
But isn't it more generic to consider it's true with another scalar?
Yeah, let me show you. We will show you next time because phi will be the potential. her psi will be the green function we are looking for. Okay, and the green function is very easy, just like this one. That's the green function. This is the green function, the simplest green function. Okay, because we will introduce, right now we just introduce Green's theorem. Next time we will introduce green function. And we will generalize the green function. And we show you the green with the green function. Once we found the green function, we got almost everything. Almost everything. That's our purpose. So this section is find the green function. Once we find the green function, don't worry, green function, very easy. Just like this one. This is the green function for infinite space. For infinite space, this is the green function. Okay.
So the question I just asked, that additional scalar will be included in the Green's function. That's what you mean?
That's possible. That's possible.
Okay.
Okay.
Okay, thanks.
If no other question, I will show you the delta function, not delta variant. It's a delta function. The definition of the delta function is here. When delta, just like this one, this is the delta function. And this is x. And this is delta function. So x minus a will be 0 if x is not equal to a. If x is not equal to a, then this one will be 0, 0, 0 elsewhere. And then a1 is here, a2 is here. A is somewhere between a1 and a2, just here, okay? So after the integration, a1 to a2 delta x minus a, it will be 1. So passing through integration, passing through this region, then it will be 1. The delta function is defined in terms of an integral. In terms of an integral, it takes an integration to bring out its full meaning. Okay, that's very important. That's very important. Takes an integration to bring out its full meaning. 要透过积分才能够把它的物理给带出来，它的真正物理意义给带出来。Which means the real structure, the real function of delta function, we don't really care, but we care about the integration. After the integration, it should give us this property. That's the definition of delta function. Okay, let's move on. The property of delta function, if we have function x and delta x minus a, and what will happen? A is somewhere between a1 and a2. Okay, after integration, x 0, 0, 0, 0. So only when x equals a, we have value. So we got f of a. Okay, so this one is easy. And here we have different notation. Different notation, delta prime s minus a. Okay, we have a prime system here. Not prime system. This is the derivative of delta function. Derivative of delta function. Derivative means delta function 的微分。OK， delta function 的为一次分，对 x 的为一次分。对 x 的为一次分。The first derivative of delta function with respect to x. So we can use integration by parts. Okay, that's the integration by parts. And here, A1, A2, we know at A1 it should be 0. At A2 be 0 as well. So this one gives us nothing. And how about this one? This one just like this one, okay? Except here we have a prime. So here we have a prime, which means the first derivative. The first derivative. Double prime means the second derivative. 微两次分. Okay. But remember, go back. Here we have a prime system. It doesn't mean it's the derivative of x, which means another coordinates. 现在胡汉林有要问问题吗？胡
没有，
汉林 turn on
基
your
本
mic，
上
怎么样？有问题吗？
没有。
没有。Okay, so you should be careful because we have two notation. One is prime, just denote the first derivative. Double prime, second derivative. Triple prime, third derivative. 为一次，为两次，为三次。But here, prime just means another coordinates. 另外一个坐标系统。另外一个 source 的坐标系统，然后 unprime 是一个 observer 的坐标系统。So normally we will use unprime system to denote the observer's coordinate system, and prime to denote the source coordinates. Okay. That's the major difference here. So we should be careful. So just like this equation, 1.35, 1.36. Here is the integration with respect to unprime. But now we change to prime. Just a moment. Let me answer this form. That's quite important. 哎，李董你好，因为我现在在线上上课，所以我不能接您的电话。我下午打给您，下课是12点了，我下午再打给您。抱歉。好。Okay, I'm sorry. Okay, so be careful about prime and unprime. The meaning is different. Okay, but I know most of the students will be easily confused at this moment. So I will reiterate the meaning of the notation over and over again. So therefore, this one is easy. Prime. So we got this one. Next slide. Another one. Let A be the roots of this one. So this time, A is the root of f of x, just like this one. F of x, we have a single root here. It's equals to A. We have a single root. Let's point it here. Okay, so integral a1 to a2 delta f of x. So we know f of x will be 0. Then we have a value. So it will be 0 when x equals a. Okay, so we change the variable from x to f of x. Okay, just change the variable. Cancel, just like the x. So we change the variable first. Therefore, we have these new extra terms. In the old time, 10 or 20 years ago, this is a very good exercise for all the students. We spend 2 hours to solve this question, this exercise, 2 hours. I remember, very difficult. But now I use one slide to show you how to derive this equation, how to solve this problem easily. Okay, because f prime, this is the prime, the first derivative with respect to x, the first derivative. But this derivative will have two terms. One is the slope is greater than 0. The other is slope is less than 0. That's different. Why? We will consider what's the difference. Okay, the difference just like, let me show you. Let me change to here. Sorry, not very beautiful. Let me try again. Try again. What? Just imagine we have a space to be A1, A2, A1, A2, and this is f of x. Integration from here to here will be the area. You might say integration from A2 to A1 is still the area. That should be the same. Is that right? Integration from A1 to A2, f of x dx. Integration from A1 to A2, A2 to A1, f of x dx. Just the surface, that should be the same. No, they differ by a minus sign. Differ by a minus sign because the x is increased in the positive. However, in this case, it's decreased. The x will be negative. So it should be a minus sign here. That's the major difference. This case, similar to this idea. Okay, it's a single integration problem, but many students will be confused. Many students will be confused. Okay. Many students will be confused. Okay, because of these properties. Okay, therefore, when the slope is negative, when the slope is negative, we will have a minus sign here, Okay, the slope is negative, we will have a minus sign here. In both expressions above, the integration is from a smaller value to a larger value, and as in the definition of the delta function, from a smaller to a larger. Therefore, we have a minus sign here. Okay, that's the major difference. Okay, minus sign, and therefore we use, in order to use a shorthand notation, we just write absolute value, a notation, absolute value. We don't care about positive or negative slope. We just use absolute value. Okay, and so compare with 2. What is 2? Go back to 2 here. 2 is here. F of x can be rewrite into this one, delta s. So just this is the major difference. If x is multiple roots more than 1, 重根、2重根、3重根、4重根, okay, we will have another problem, but it's still not that difficult. Okay. Let me show you. Therefore, because of this property, so it's clear, delta a minus x will be equals to delta x minus a, and delta cx will be equals to delta x divided by absolute value of c. So you can prove, you can show these two property with this property, okay, easily. Okay, just keep this in mind. In the old time, professors prefer to give us this one as an exercise. And normally it takes about 2 hours. 2 hours. But now just one slide. Because this is a very important properties. And we will use this property frequently. Therefore, I just show you how to derive this equation. Okay, we have an extension. What time is it? Wow, very slow. Extension to 3 dimensions. We have an extension to 3 dimensions from Cartesian Coordinate. Cartesian Coordinates 直角坐标系统，或是笛卡尔坐标系统。S1, S2, X3, or XYZ, up to you. If you use computer, you will use S1, S2, X3. If you handwrite, you will prefer XYZ. Okay, just a notation. Delta x minus x prime, the definition is triple product of this one, this one, this one, and this one. Triple product. Delta S1 minus S1 prime times delta S2 minus S2 prime times delta X3 minus X3 prime. Okay, so the integral, this notation is still the same, just separate into 3 variables, 3 independent variables. So the result will be the same. If inside the volume, outside the volume, nothing. Inside the volume, then the volume V, then it will be 1. Okay? For a cylindrical coordinate, cylinder, 圆柱形的 cylindrical, 圆柱形的 cylindrical coordinates. Coordinates, we need S, Y, Z more than 2. Therefore, more than 1, so we use X. Coordinates. X here, rho, phi, Z. Okay? So for delta function, delta x minus x prime, we write as this form. Rho minus rho prime times delta phi minus phi prime. Delta z minus z prime. But remember, we have a proportional constant here. Actually, this one, you can rewrite into rho, d phi, dz. And this rho will cancel with this one. Okay. Okay. So eventually, we have 3 delta functions. 1, 2, 3. That's the volume integral. Volume integral, 体积分. So once again, we have a 0 here outside, 1 here inside. Okay, now we have shown 3 symbols of phi. Just a moment. We just shown 3 symbols of phi. Remember, we have this phi, and we define this phi, and we have phi, 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 phi italic, phi capital, phi. There's another phi. That's also pronounced as phi. Pronounced as phi. Okay. It's very difficult to. I'm sorry. I personally prefer Apple Pencil, and if possible, I do wish to write on the screen, but right now I cannot do that because my screen is not a touch screen. Therefore, I will use touchpad, 手写板, and touchpad is not friendly to me. Okay, like this one. So my symbol is ugly. Yeah, very ugly. Sorry. Very ugly. Okay, so these three symbols pronounced as phi, P-H-I. Where are you? P-H-I, phi. Okay, pronounced as phi. Okay, next page. Let's consider cylindrical coordinates. This time we have r, theta, phi. R is the separation from origin, 原点, sorry. R, theta is the angle between Z and R. Phi is the angle between x-axis and here. Okay, so in terms of cylindrical coordinate, delta function will be here. R squared sine theta, delta r minus r prime, delta theta minus theta prime, delta phi minus phi prime. Or you can rewrite this one into here. Cosine theta minus cosine theta prime. Okay, just move, just like a derivative, first derivative of this notation. So just move to here, and we have r squared. And delta cosine theta, the simple proof, okay, the same. And then this take a volume integral. So we can rewrite this one. Aha, cancel with this one. Cancel with this one. Cosine theta. Actually, it's r squared sine theta dr d theta d phi. Okay, so r squared sine theta will cancel with this one. So eventually, we have a similar equation. So we got 1 times 1 times 1. That's the volume integral. So eventually, we got a simple solution. So we will, Cartesian coordinate is relatively easy, just S, Y, Z. We're familiar with Cartesian coordinate before. Cylindrical coordinate is something new. We were used for many, many cases. Spherical coordinates. Actually, we prefer cylindrical coordinate because for optics, 光学, we will use cylindrical coordinates a lot. Spherical coordinates is also very convenient, and it will come up with some spatial function like Legendre polynomial. And cylindrical coordinate will deal with spatial function. Remember, at the beginning of this course, I told you, we have to learn some new physics, some spatial functions. Those spatial functions will help us a lot. Those spatial functions will help us to rewrite the green function. Okay, I just mentioned we don't care about the detail of the delta function. So delta function comes with many forms. Mathematicians care about the delta function, but we are physicists. We will use delta function. So the detailed structure of the delta function is not very critical to us. All we need to know is the property of the delta function. That's the most important. Okay, so problem 1. We still have 3 pages. Okay, time is enough. The first problem is try your best to write the delta function, to write the charge distribution function. Problem 1, let me read the problem 1 for you. A total charge Q is uniformly distributed around a circular ring of radius A and infinitesimal thickness. Write the charge density rho x in cylindrical coordinates. Okay, the keyword uniformly 均匀的 circular ring of radius A. This is a ring of radius A. 半径是 A， 是一个圆环。Total charge Q. Infinitesimal thickness. 根本就是细到无限小的、极细的、一点点的厚度。Of course, it's an assumption. In a real case, no such infinitesimal thickness, just an approximation. For example, if you have a wire, ultra thin wire, very thin wire, just like your hair, you can consider it as a delta function because infinitesimal. And write the charge distribution function in cylindrical coordinate. But cylindrical coordinate, we have rho, phi, and z. And this rho is exactly the same notation as this rho. We have 2 symbols use the same notation. Therefore, in order to prevent such effect, we change to R. Okay. Okay, so the solution should be, we can wild guess, 随便猜哦，大胆的猜 doesn't matter. It's a K delta, just like rho minus A, delta Z. Delta Z indicate in the XY plane. Delta rho minus A just means in the radius. In the radius, this should be R minus A. In a spherical sphere, is a sphere divided by delta Z. Okay, so it's just a ring, infinitesimal ring. So how to determine the coefficient K? K can be determined easily. Delta rho x K delta R minus A delta Z. R dr d phi dz. Okay. After integration, we know only when R equals A we have value. So just give us d phi, give us 2 pi. And this one give us A. And dz give us 1. Okay. So it's 2 pi k times A equals Q. That's total charge. Total charge equals the volume integration. So coefficient K is Q divided by 2 pi A. Okay, that's the coefficient. Coefficient is here. Okay, so it's Q divided by 2 pi A delta R minus A delta Z. OK， 黄玉，这是念右吧？黄右奇 ，please tell us your question.
Could you hear me?
You can ask your question.
Okay, so my question is that if you write the charge density distribution with delta functions, doesn't it mean that the charge density is finite on the circular ring?
Just an approximation, because in a real case, no such ring, right?
Yes.
No infinitesimal ring. Yeah, but we can use delta function to approximate this kind of condition.
Oh, because the value of this circular ring is actually 0. I mean, theoretically. So it should be finite. Am I right?
Yeah.
Oh, I see.
Yeah.
Thank you.
Yeah, right. Okay, so that's the first problem. Let's have a look. This problem is easy, but you should be familiar with this one because I will ask you how to write. If we have a spherical shell, 一个球壳, how to write the charge distribution. If we have a line of charge, infinitesimal small line of charge, how to write the charge distribution, charge density. Okay. Second, let me show you this one. Proof Laplacian 1 over R equals minus 4 pi delta R. Prove this one. That is this one. Okay, similar to this one. So now I will show you how to prove this one. That's the definition of delta R. Remember, delta R will be 0 if R is not equals to 0. Okay? Only when R is equals to the origin, 原点, then it will have value. Otherwise, no contribution. So the volume integration is always greater than this one. It will be 1. To prove this property, we separate into 2 parts. Part 1 is here, outside, and R just outside, not cover the volume here. The other is, enclose this origin. Then it will be minus 4 pi. Okay, it's very convenient to use the spherical coordinate to prove 1. So Laplacian is here. Okay, I assume you should be familiar with Laplacian because we use this one to solve hydrogen atom. We use this one to solve Legendre polynomial. So we solve this Laplacian over and over again. It's not new to you. So you should be familiar with this one. Because of electrodynamics require many mathematical skill. Therefore, I do not encourage the third year student to take this course. 大三的学生，我觉得修这个课有点太早了。大四还可以，大三有点太早了。大三学到这么硬的数学，会有点揠苗助长，所以我不太鼓励大家大三就来修。大四 OK， 你基本的数学已经有了，你修这个课 OK 的 ，OK。硕一、博一当然 OK 了。但是大三你要斟酌一点哈，我们有几位大三的同学，你的物理数学要够强，应用数学也要够好，然后你也要修过量子物理，你会对这些 spatial function 比较有感觉。Otherwise， 你会觉得这就是数学， 你看不出它的物理来。OK， 这是我的经验了。我已经算是数学很好的人了，我所有的 Applied Mathematics 跟物理数学几乎都是 A 加的。可是我在学电动的第一次的时候，我只学会数学，而且学完之后我不知道我在学什么。很诚实的跟大家讲，就是这样。好像我都懂，但是我真的懂吗 ？Question mark. Yeah. Okay. Laplacian 1 over r will be 1 over r, just this one, because no contribute, 0, 0. So only this one give us the value. So the first derivative of 1 over r will give us a minus sign here. Okay? Because outside the origin. So obviously this one will be 1. And then this one will be 0. So it's clear. To prove this one is very easy. How about this one? To prove this one, we need to introduce the divergence theorem once again. To prove the second property, this one will be rewrite into divergence gradient 1 over r. It will be equals to this one. It's the unit vector pointing outward from inside out. And the surface enclose this volume, enclose 4 pi, enclose the volume. So just change the variable from volume integral to surface integral. And then we can write this one. This one is easy. Minus 1 over r squared, e r direction. So this one gives us minus r squared divided by r squared. Okay, because surface is r squared d omega. The omega is the solid angle. The sine theta, the theta, the phi. Okay, it just represents the solid angle. So r squared. So eventually this one gives us minus 4 pi. Okay, it gives us minus 4 pi. So change to a coordinate system. So this one is just prove this one, the simplest case. But we can change to a coordinate system in which r equals r minus x prime. Griffiths call this one as a separation vector. Separation vector. Actually, Griffiths use a different notation. Griffiths use a different notation. Remember, Griffiths use this notation. That's Griffiths notation, but Jackson just write it down. Griffiths use this notation. This notation is difficult to type. It's easy to write, but difficult to type. 不好打字啊，因为这个是 spatial notation， 不好找。Difficult to type. Okay, so Jackson is friendly. He just write it down. So in general, we have this one. We got this one. Okay, we got this one. Okay, we have proved this one. Maybe what? Oh, the time is up. We are running out of time. I wish to introduce another application of the Green's theorem. That's the uniqueness theorem. Next time. So I will stop here. You are welcome to ask any questions. Some students told me they do not receive the notification. I don't know why. We use the e-learn system to notify you, but I know some of the email will go to the junk mail or advertisement mail， 会跑到垃圾邮件或者是跑去那个广告邮件，所以这个我没有办法处理耶，这个你要把它救回来。所以你有空没事，你要看看你的垃圾邮件信箱里面有没有重要的讯息。OK， 我们透过system， 或者是你 frequently check e-learn system， 会有最新的消息会公布在 e-learn system 里面。OK， 然后你要形成一个 group， 几个同学要凑成一个 group。要跟同学保持良好的关系，所以万一有什么 information， 可以及时的通知你。当然，最好的是我们回到教室上课。OK， that's my wish. OK， any question? Any question so far?
老师，请问一下，那个如果下一次上课，如果还是线上，会是用 Google Meet 还是用这一个？
用这个咯。
好，谢谢老师。
对，因为我们的 lecture note 已经改过来了，已经改成这个了。我们 lecture note 已经改成 Webex， 已经改了。好，下一位 ，next one。
Hello.
Yeah， 谈到您那边。
Right. Can I ask which edition of Jackson you are using? Because I kind of find I can rematch the equation you're.
Which
using.
one?
Which edition of Jackson you are using? I'm using 3rd edition.
Yeah, me too. 3rd edition.
Right. But
Any question?
Right, the equation and questions you mentioned during the class, I can't really find them. Kind of mismatch.
Oh, really?
I don't know why.
If you found they are not correspond to the correct equation, please let me know. I will correct this problem.
Okay.
Okay. Actually, you can easily find an electronic version of Jackson. I don't want to tell you how to download that.
Yeah, I know how to find it.
Okay. Any other questions? If no other questions, how about our TA? 洪俊，你今天要讲习题吗？
下礼拜开始，下礼拜。
Starting from next week. Okay. Remember, Happy Mid-Autumn Festival. Mid-Autumn Festival. 好，大家中秋节愉快。See you next time. 拜拜。
谢谢。
不客气。881。停止视讯嘛。
老师。
嘿。
想问一下，这堂课有录影吗？
有，现在正在关掉。
哦，好。
关掉。
好，谢谢老师。
要如何关掉？暂停吗？对，会上传到 YouTube 了，但是我该如何关掉？How to turn off？
我可以关，要我关吗？
啊，你帮我关掉好了，不要录影了。啊，这录到哪里去啊，洪俊？
我不确定诶，应该是网络空间吗？还是老师的电脑，或者是我的电脑？反正我先关掉试试看。
Google Meet 是录到那个 Google Drive 去，可是这个会跑去哪里？
好，我先关掉试试看。
好，你。